Hi, welcome to this video on geometric sequences. This is lesson 2A-2, and we're going to pick back up on the conversation of sequences. Different than arithmetic sequences, which have a common difference, geometric sequences, we will learn, will have a common ratio. So, you'll be successful if you can identify what a geometric sequence is, if you can find the common ratio of a geometric sequence, if you can find any term in a geometric sequence, and you can understand rate of change for a geometric sequence. Reminder, a geometric sequence is a function with a graph consisting of discrete points, or it can be a list of numbers instead of a continuous curve. And so here's an example of what an arithmetic sequence looks like, and then here is an example of what a geometric sequence looks like. What do you notice in terms of comparison between the two? Let's talk about what a geometric sequence is. A geometric sequence, often abbreviated as this, so G sub n, this will be a list, your nth term, whatever your nth term is, will have successive terms that have a common ratio R, or a constant proportional change. And so what you want to do in order to determine R is just take any term and you divide by the term before it. Right? So in this example right here, I have 3, 6, 12, 24. To find any the ratio, you can take any term, 6, and divide by the term before it, 3, right? Which will be equal to, if I took 12 and I divided by the term before it, or I took 24 and I divided by the term before it. Our common ratio, or geometric proportional change, is 2. And hopefully by now what you picked up on in this example is that you have numbers that are multiplying. I'm multiplying by 2. Okay, and so we say that we have a common ratio. Now it is possible too to see numbers decrease. So you could take like the reverse of this, right? I'll put this up here. So what if I had 24, 12, 6, 3? So here it looks like I'm dividing by 2. Well, my ratio will be a fraction. Okay, so if you get this proportional, decreasing proportionality, your ratio is going to be a fraction, okay? And again, I can take any term and I divide by the term before it. So here it would be 1/2. So we're still multiplying by a common ratio. It's just this ratio is a fraction, right? 1/2, between 0 and 1. Okay. So how do we go ahead and, I guess, first of all, how do we read geometric sequences? So again, a geometric sequence, G sub n, will have terms listed like this. Our first term, G sub 1, is 3. Our second term is G sub 2, so on and so forth. And our initial term, G sub 0 or G naught, will be your first term, and again we do the opposite. So I'm going to divide by R. So in this case, if I'm multiplying by 2, I do the opposite. I'm going to divide by 2 in order to find my initial value. Okay. Now, initial values are important because we can write a explicit equation or a function to model our terms using that initial value. And so here, again, this is the format of how we write an equation to find geometric sequences. So G sub n will be equal to G sub naught, this is your initial value, times R to the power of n. So if I want my second term, I'm going to go ahead and plug in 2 up here for n, and then that will multiply my initial value times our common ratio 2 times. Now, what if I don't have my initial value, or it's going to take me too long or be too difficult to find my initial value? You can use any term in the sequence. I can use the third term, the fourth term, and all we do is we start with that term, but then we subtract whatever term that is from our power of n, okay? So these are our 2 formats that we use to write equations. And then here they are kind of like linked in the example of the 3, 6, 12, 24. So using our initial value of 1.5, I can find any term by multiplying it by 2, how many ever times I need to the power of n. Well, what if I don't have my 1.5 initial value? Well, I can use the third term, which is 12. I start at 12 and I multiply by 2. All I have to do is subtract my power, right, by 3, because it's the third term. The 12 was the third term. All right, so let's go ahead and let's look at some examples that can appear. All right, example number 1. Values of the terms of a geometric sequence are graphed in the figure. Use the information in the figure about the geometric sequence to answer the questions. They say here, well, you know what I want to do? I'm going to start on C. What is the third term? G sub 3. And G sub 3 will be my third term. So here's 3, and I'm going to go up, and it looks like it is 4. So my third term is 4. Okay. Well, what's my common ratio? How are these numbers changing? And what I like to do is I like to list them. So I have 1, then I have 2, then I have 4, then I have, it looks like 8. So here, my ratio, R, is going to be equal to, okay, any term divided by the term before it. So my ratio here is 2. Okay. Based upon this, what would be my initial term? G sub 0. Well, this is going to be G sub 1 divided by this ratio. So my first term was 1, and we divide by my ratio, which is 2. So I have an initial value of 1/2. There's my initial value. Okay, what would be the sixth term? What would be the sixth term? So in order to find the sixth term, I need to go ahead and I need to have the fifth term, and I'm going to multiply times R. Well, I don't know what my fifth term is, right? But I could find it, my fifth term, if I double 8. So that's going to be 8 times 2, right? So if I'm at 16, okay, if I double, if it's 8, my next one's going to be 16. Sorry, I'm just overcomplicating this. And then I multiply that by 2, we get 32. So, sorry, that should say 16. I made that way harder than it needed to be. It wasn't that deep. Okay? So my sixth term would be 32, way up here. And do you notice how this graph grows really, really fast? E, write an expression for the nth term using G sub n equals G naught times R to the power of n. Okay, pretty simple here. We found out that our initial value is 1/2, and we're multiplying by 2 to the power of n. There you go. They say write an expression for the nth term using G sub n equals G sub k times R to the power of n minus k if the kth term is represented by 4, 8. Okay, so G sub n is equal to, my fourth term is 8, and I'm going to multiply by 2 to the power of n minus 8 was the fourth term, so I subtract 4. And there you go. There are the two general equations for this geometric sequence. Here's a practice problem. They give you a list of numbers. Go ahead, please pause video, try this one, and I'll show you the solutions here in a second. Okay, with a geometric sequence of 4, 12, 36, 108, 324, I hope you picked up on that we are multiplying by 3. Your common ratio is 3. The initial term, if we take our first term and divide by that common ratio, which is 3, you get 4/3. The fourth term you can read in this list is 108. And then the sixth term, I'm going to have to go ahead. They give us the fifth term. I'm going to have to multiply 324 times 3, which would give us 972. Usually for geometric sequence questions, they're usually calculator active. Hopefully you can find 324 multiplying by 3. But if not, usually we have calculators for geometric sequence questions. So have Desmos handy. We're definitely going to use it coming up. And then here's our two expressions for our initial value used expression, right? And again, I want you to see the similarities here. I'm using the 0th term, which is 4/3. So essentially, isn't that the same as n minus 0, right? If it's just n. So the 0th term, 4/3. Here, they wanted us to use the first term, which was 4. So I start with 4 and multiply by 4/3, and I raise it to the power of n minus 1. Okay, so did you get it? Hopefully you did. All right. Here is a practice question. They say for a geometric sequence, the common ratio is 1/4 and the third term is 680. What is the 12th term as a decimal approximation? So this will be calculator active. I'll break this up into two kind of parts for you here. First, please go ahead. I want you to find the equation. Then you can find G sub 12. Okay, so please pause me. Try this one. Try to write an equation for this, and then I'll come back on, and then I'll let you find this. Okay, here is your equation for your geometric sequence. They give you the common ratio, 1/4, and they say your third term is 680. So we start with 680 and we multiply by 1/4, and we do that to the power of n minus 3. So if you want to find g sub 12, go ahead, plug it in, find g sub 12. Okay, here you go. Using that equation, we can go ahead and plug in 12. 12 minus 3 gives you 9, so you have 680 times 1/4 to the power of 9. And that should have given you 0.00259. Okay. All right. Write the first 5 terms of a geometric sequence with a first term of 4 and a common ratio of -1/2. Well, my first term they give me is 4, and my common ratio is -1/2. So I'm going to multiply 4 times -1/2. That's going to be -2. Next one will be a +1. Next one, a -1/2. Next one, a +1/4. Kind of a cool thing that comes from a ratio that has a negative ratio is that you're going to get what's called an alternating sequence. But this will never be a function. It will never be a function. Only discrete values because it bounces. Okay, so you're not going to get a function there. Okay, next question. For a geometric sequence S sub n, S sub 4 equals 8 and S sub 7 equals 27. What is the value of S sub 15 as a decimal approximation? Well, what I need first, in order to find S sub 15, I need to find S sub n. And S sub n is going to be equal to S sub k times r to the power of n minus k. So there's my equation for a geometric sequence, and I have values, right? I know like my 7th term is 27, so I can use that point, right? I can use 7, 27, but what I'm missing is r. I don't know what r is. So what I'm going to do is I'm going to set up one of these equations using both of these values. I'm going to let S sub 4 be my S sub k term, and my S sub 7 be my S sub n term. So here's what I'm gonna do. So we get I guess, yeah. So 27 is equal to, I start at 8 and I'm gonna multiply times my ratio how many times? Well, if I want the 7th term, I plug in 7 and I started at the 4th term. So, and you can kind of think about this intuitively. Didn't I multiply times the common ratio 3 times, right? To get to 5, to get to 6, to get to 7. Okay, so what we end up getting here is I get 27 is equal to 8 times r to the power of 3. If my pen will let me write. R to the power of 3. Okay, so I can go ahead and now solve for r. I can divide both sides by 8. And we get r cubed equals 27 over 8. And then I can go ahead and take a cube root of both sides. Okay, and I get the cube root of 27 divided by the cube root of 8, which gives me 3 over 2. Okay, so there's my ratio. My ratio is 3/2. So here is my equation. So S sub n equals, I'm going to use 27 times 3/2 to the power of n minus 7. So there's my new equation. Okay, so you use the two givens to find r, and then now I'm just going to pick one. You could do the same thing with using the other point. And they want the 15th term. So S sub 15 is going to equal 27 times 3/2 to the power of 15 minus 7, which will give us 8. So again, this is you know, a calculator active question. So I'm going to go ahead and plug this in. So 27 times 3 divided by 2 to the power of 8. 8. Okay, and we get 691.980. Remember, always for AP, 3 decimal places, rounded or truncated. I like to have my students round, but if you truncate on the AP exam, that's also fine. Okay? All right, here is a practice problem for you, kind of the same idea, same structure as the last one. Please pause me, try this one. All right, here is the solution to this practice problem. They want the 17th term of your geometric sequence. So given two terms, we have to first find that common ratio. And what we do is we can just set up an equation, and we have to take the fourth root. So hopefully you used a calculator, or you reduced the 32 over 162 to give you 16 over 81. And those fourth roots are known, so we get 2/3. So our equation is g sub n equals 32 times 2/3 to the power of n minus 9. Again, I'm subtracting 9 because I used the 9th term to start with, 32. And then I just evaluate. So I plug in 17, and your calculator should have given you 1.2485. Did you get it? Hopefully you did. Okay, some practice multiple choice questions that you could see on the AP exam. Which of the following includes the input-output pair 2, 6 and 3, 12? Go ahead, pause me, try this, and we'll look at it here in a second. Okay, hopefully you looked at this one. This could be arithmetic or it could be geometric. If it's arithmetic, you have a common difference of 6. So C is going to go right out the window right away because they say 2 times n. That common difference would be 6. So maybe A, but if I list this, my term before, the first term would be 0, and then my initial term would be -6. So this is set up to be with the initial value. So I'm missing that -6, -6. That would be correct if it had that. So it's not arithmetic. Let's look at our geometric options. The ratio here is 2. I'm multiplying from 6 to 12. I multiplied by 2. Both of these have this. So let's go ahead and go to the format. So this format here where they say just n, that's n minus 0. Is my 0th term 6? Well, looking at it right here, my first term is 3, and so my 0th term would be 3/2. 3/2. So, nope, not this one. And then here they say the first term is 3. Is that true? Yes, this one is true. So the answer, D. Hopefully you got that answer. Okay, next practice one. Please go ahead, pause me. Try this example. Okay, on this one, hopefully the pattern's pretty easy to see. 8 to -4, -6, that's a constant rate of change. That would be a common difference, an arithmetic sequence with a common difference. So, not too difficult on that one, okay? All right, next practice problem. Please go ahead, pause me. This is definitely calculator active, so please use a calculator on this one. All right, so in this context, they give us a geometric sequence. They say the third term is 1,200. That's the insect population. On the 10th day, it is 6,000. So we have to find this common ratio, or this rate of change, this proportional rate of change. So we can set up an equation. We know R was multiplied times itself 7 times. So you divide these, you get 60 over 12, which is just 5. And so you take the 7th root of 5 and you get 1.2584. Again, you definitely need a calculator for this. And then you have to find g of 5. So we plug 5 into our equation, which is 1,200 times the 7th root of 5 to the power of 5 minus 3. Okay? And you should have got 1900.584, and so B is your answer. Okay, last practice one. What is the constant proportional change of a geometric sequence with a first term of 6 and a fourth term of 10.368? All right, pause it, try this one. Okay, hopefully you tried this one and you set up the equation in order to find R. Divide by 6, take the cube root of each side, and you get 1.2. Okay, that's going to do it for this video. Hopefully you learned what a geometric sequence is, how to find the common ratio of a geometric sequence, how to find any term using general equations, and you understand that the rate of change for a geometric sequence is proportional. It is proportional, leading to these types of functions. What kind of functions could this be? We'll talk about that in the next video. See you later.